Hello, guys. Good morning, everyone. So, I'm Sumit Nahak. I had secured All India rank 691 in NEET, and today I am starting a new chapter of chemistry, P block elements. Okay. So, before starting the chapter P block elements, I will just try to brief the whole chapter in 2 minutes. Then we'll start the previous year questions. Okay. So, P block element contains group 13 to group 18 elements. Okay. P block is on the right side of the periodic table. If you remember, this is how our periodic table looks like. This is how our periodic table looks like. And this is on the right side, our P block elements lies. Okay. Group 13 to group 18. These are our P block elements. Yeah. So what is special about them? If you remember, this is the S block, this is the D block, this is the P, and this is the F block. Okay. So what is the special property which makes them special in the periodic table? P block. What is the special property they have? First though, P block elements, they are electronegative elements. They have high electronegativity, and most of them are non-metals. Most of them. I'm using the word most of them. Most of them are non-metallic. Then most of them have all the elements have an electronic configuration which ends with p, which ends with the orbital p. Mane, if you try to draw their electronic configuration of any of the element in p block, they'll have their last electron. They'll have their last electron in the p orbital. Okay. What are the orbitals? S, P, D, and F. Okay. If I am taking an example of nitrogen has an atomic number 7. So the electronic configuration of nitrogen will be 1s2, 2s2, 2p3. Okay. So all the elements of periodic p block will have last electrons in the p orbital. That is why they are p block elements. Okay. And everyone will have high electronegativity, and most of them are non-metallic. Most of them are non-metallic. And the other properties are they'll have a high ionization enthalpy. They'll have high ionization enthalpy. And the other properties of p block elements we'll learn in the chapter as we proceed to the questions. Okay. Through the questions we'll learn all the properties of the p block elements, and what are the reactions that you need to remember in the p block elements that are being repeatedly asked in the previous year questions. So everything we'll learn in the chapter as we proceed to the questions. Okay. So guys, let's begin. So I'm beginning with the question number 1. Previous year question, P block elements. The first question is, when urea reacts with water to form A. When urea reacts with water, whatever they're asking you in question, please write it down yourself. Please write it down yourself in a separate copy, or try to form a reaction from whatever they're asking you, so that it will be easy for you to solve the question properly. Okay. So urea when reacts with water, it gives a compound A. It gives a compound A. Okay. Then A, which will decompose to form B. A will decompose to form B. Decompose means when you heat A, it will give B. Then they are saying, when B is passed through copper, copper aqueous solution, a deep blue color solution C is formed. C is what? Deep blue colored solution. Deep blue colored solution. Yeah. So what is the formula for C that we need to find out? First, what is the formula for urea? Urea ka formula, what is the urea's formula? Urea is CONH2 twice. CONH2 twice. Okay, which you can also write it as NH2 CONH2. So when this urea reacts with water, what it will give? What it will give? It will give rise to NH ammonium carbonate. It will give rise to ammonium carbonate. NH4 twice CO3. Okay, it will give rise to ammonium carbonate. And when ammonium carbonate is heated, when ammonium carbonate is heated, it will give rise to B. And what will be B? NH3 plus carbonate or carbon dioxide it will give. And ammonia and carbon dioxide it will give. And when this B, ammonia, is reacted with copper, it will give a deep blue colored solution. It will give a deep blue colored solution. So when copper reacts with ammonia, what compound will form which will give a deep blue colored solution? That you need to find out. When copper is reacting with ammonia or NH3, it will give rise to what? Copper ammonium copper complex. This will be the compound which will form. Okay, and this compound has deep blue color. This compound has a color of blue. This compound is blue colored compound. Okay, CuNH34. So in which option copper ammonium complex is present? Option number A. So option number A is the correct answer. Okay, did you understand what happened here? First they told urea when reacted with water. When urea reacts with water, it will give rise to ammonium carbonate. Okay, and then when ammonium carbonate is heated, it will decompose to ammonia and carbon dioxide. And then they told at the last part, when the ammonia reacts with copper, it gives rise to deep blue colored solution. So what will be the deep blue color solution? Copper ammonium complex. Okay. So with this, I'll proceed to next question. Question number 2. Question number 2 says, what are the oxidation state for H4P2O5, H4P2O6, H4P2O7? Yeah. What are the oxidation states? What are the oxidation states for this compound? In the chapter redox reaction in class 11th, if you have if you have studied the redox reaction chapter in class 11, then you must have heard how to calculate oxidation states. There are a number of ways to calculate oxidation states of the compound. Okay, but the most appropriate way to calculate the oxidation state is by drawing their by drawing their by drawing their uh, formula, by drawing their formula or structure, chemical structure. Okay, it is the most appropriate way to find out their oxidation state. Okay, so I will start with H4P2O5. Okay, if you remember how to draw H4P2O5, then H4P2O6, I'll draw the structure, then we'll find out the oxidation state. H4P2O7. H4P2O7 can be drawn as P double bond O, P single bond OH, P single bond OH, single bond O. You have to remember this, guys, or else it's very difficult. You can see a table in NCERT in P block. There a table is given, and below the table, so many figures are given. So many structures of these compounds are given. Please draw it again and again so that you will remember the structures exactly as given in NCERT. Okay, or else it will be very difficult for you to solve the questions like this. So I'll draw H4P2O7. This is the structure, guys. H4P2O7. So what is the oxidation state for H4 oxidation state of phosphorus here? What is the oxidation state? Here, P is P is in a single bond with oxygen. So from here it is getting +1. From this bond, it's getting +1. From here, it's getting +1 again. It's single bond with oxygen, again +1. From here, two bonds with oxygen, so +2. So by adding up +2, 1, 1, 1, we get the oxidation state of phosphorus here is H plus 5. H4P2O6. H4P2O6. In H4P2O6, I'll again draw the diagram. This will be the structure, guys. This is the structure for H4P2O6. Okay, so phosphorus is a single bond with phosphorus itself. So here it will this bond will not give any oxidation state to the phosphorus, but this single bond with oxygen again +1, again one more single bond with oxygen +1, two single bonds will give +2. So phosphorus is the total oxidation state here +4. Okay, so which option says +5 in H4P2O7 and +4 in H4P2O6? It is option number D. Option number D. +3, +4, and +5. Okay, guys, and I'll draw H4P2O5 for you. It has two POH bond, two PH bond. It has two POH bonds and two PO bonds. Okay, so this is the structure for H4P2O5. This is the structure for H4P2O6. This is the structure for H4P2O7. Okay, oxygen state of +3. Two bonds with oxygen and one bond here with oxygen. So +2, +1, +3. Okay. So I hope you understood how to calculate the oxidation states in this compounds. It's very easy if you remember the structures of these compounds, or it should be difficult. So again and again, draw the diagrams. You will eventually remember. So moving on to question number 3. How many bridging oxygen atoms present in P4O10? How many oxygen atoms present in P4O10? So again, to find out the bridging oxygen atoms present in the compound P4O10, what do we have to do? Again, you have to draw the diagram for P4O7, P4O10. This is, I think, a very old question of NEET. I mean, before 2000, or maybe the question is from 2001 or 2, which has been asked 20 years back. Nowadays, NTA doesn't ask this kind of questions, but yeah, I will say you should know how to draw the diagram, okay, up for P4O10. But nowadays NTA do not ask this kind of questions nowadays. P4O10. So how will you draw P4O10? So see, guys, I'll tell you how to a easy trick to draw this diagram for P4O10. First, you know it has 4 phosphorus atoms. It has 4 phosphorus atoms. Draw 4 phosphorus atoms first. Then what you have to do? Draw 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 oxygen atoms with a double give double bond to phosphorus and draw a double bonded PO molecule. Make double bond with P with oxygen. Yeah. Then how many oxygens you are left with? 6 more oxygens you are left with. Again, give one oxygen to each. See guys how I am drawing. This is the easiest way you can draw. One oxygen atom each. Yeah. So how many oxygens now you are left with? Four phosphorus atoms has been used, and eight oxygen atoms has been used. Two more oxygens you are left with. Two more oxygens you are left with. So two more oxygens, how you draw? Connect the opposite side phosphorus. Connect the opposite side phosphorus with a oxygen. Opposite side phosphoruses. Okay. So now the structure is done. The structure is P4O10. Okay. I'll tell you again how to draw this, how to draw the P4O10 diagram. See, first you draw 4 phosphorus atoms at 4 corners of a square or rhombus, whatever you take. 4 phosphorus. Then you connect all the phosphorus with a oxygen with single bond, like I did. This bond. Okay, and all the phosphorus has oxygen atom which is connected to it through a double bond. Everyone will have a double bonded oxygen atom, everyone will have a single bonded oxygen atom. So 8 oxygen atoms has been used, and for the rest of the 2 oxygen atoms, connect the oppositely arranged phosphorus atoms with by using a oxygen atom. That's it. So coming back to the question, how many bridging oxygen does it have? So how many bridging oxygen? What do you mean by a bridging oxygen? What do you mean by a bridging oxygen? Bridging oxygen means the oxygen which bridges between 2 phosphorus atoms. The oxygen, I'll write the definition. The oxygen atom which bridges between 2 phosphorus atoms. 2 phosphorus atoms. So how many oxygens are bridging between 2 phosphorus atoms? This oxygen is bridging between 2 phosphorus atoms. Oxygen number 1. Again this is bridging between 2 phosphorus. Oxygen number 2, 3, 4, 5, 6. So there are 6 bridging oxygen atoms present in P4O10. Option number B. Okay, guys. So with this, I'll move to question number 4. Question number 4 says nitrogen forms N2. Nitrogen can form N2. But phosphorus does not form P2, it forms P4. But phosphorus does not form P2, it forms P4. Why? Why does it form P4? Why does it form P4? The reason is, see guys, nitrogen and phosphorus both are present in group 15 of the periodic table. They both are present in group 15 of the periodic table. So normally what will we expect? If nitrogen can form P2, phosphorus should also be able to form P2. Yeah, because both are in group 15, both has the same valency, both have same number of outer shell electrons, so both should form the same compound. If it is forming N2, it should also be able to form P2, but it is not happening. Why? In inorganic chemistry, you'll find plenty of exceptions. Okay, so it is one of those. You'll find plenty of exceptions. Why it is forming? Why it is not able to form P2? Because I'll draw the diagram for N2, then you'll understand. N2, how it is being formed. It is the electronic configuration of N2. N2 forms N triple bond N. This is the structure for N. If you will draw the orbitals for N, if these are the p orbitals, it overlaps with each other. Okay, this is the sigma bond, these are the pi bonds. Yeah, and in N2, these pi bonds are very strong. P pi bonds are very strong in N2. But if in case P2 is formed, for phosphorus, these p pi bonds are not strong. These p pi bonds are not strong. These are the very weak bond. This is a very weak bond. That is the reason why P2 is not formed. Okay, P forms P4. Phosphorus forms P4. Okay, why? Because P pi is a very weak bond. The way I have explained, I think you will never forget this because I've drawn the diagram and tried to explain you very in a simplified way. Okay, I hope you never forget this. P2 never exists because P pi bonds are very weak. That's it. So moving on to question number 5. Question number 5 says, which one of the following fertilizers has the highest nitrogen percentage? Which one of the following has highest nitrogen percentage? How will you calculate the amount of nitrogen? See, first, which one of the following? So we'll go with option A first. What is the option A? Ammonium sulfate. Draw the diagram for ammonium sulfate. Ammonium sulfate. This is ammonium sulfate. This is ammonium sulfate. In ammonium sulfate, what is the percentage of nitrogen? How many nitrogen are present? 2 nitrogen are present, 8 hydrogen are present, 1 sulfur is present, 4 oxygen is present. Okay, so what is the percentage of nitrogen? To calculate the percentage of nitrogen, you can calculate by using simple mathematics. Okay, what is the atomic mass for nitrogen? 14. 14 into 2 is 28. 28 upon 28 plus 8. 8 means hydrogen atomic mass is 1. 1 into 8. For sulfur, atomic mass is 64. Okay. And for oxygen, atomic mass is again 16. 16 into 4, 64 into 100. Okay. So you have to solve this. 28 upon 64 plus 64 will be 128. 128 plus 8 is 136. 136 plus 28 is 164. 164 into 100. So the percentage of nitrogen here will be 21.2. Percentage of nitrogen here will be 21.2. So in the same way, you have to calculate what is the percentage of nitrogen in all the compounds. So let's see guys, calculate. Coming to option number B, says calcium cyanamide. Calcium cyanamide formula is calcium Cn twice. Cn twice. Again 28, because two nitrogen are present, you have to calculate it very fast, guys. 28 upon 28 plus carbon has carbon, two carbon are present. Okay, one carbon has atomic mass of 12. 12 into 2 is 24, plus calcium's atomic mass is 40 into 100. So this will be 28 upon 28 plus 24 will be 52. 52 plus 40 will be 92. 92 into 100 into 100. This will be 35%. Okay. Then coming back to option number C, says NH2CONH2, urea. Urea has two nitrogen atoms again. 28 upon 28 plus 4 plus 12 plus 16. Do you understand? Two nitrogen atoms, four hydrogen atoms, one carbon, one oxygen into 100. This will be equal to 28 upon 32, 44, 60 into 100. This will be equal to 28 up 2800 upon 2800 upon 60. 2800 upon 60 will be equal to 47, near around 47. 47 percentage. Then option D, ammonium nitrate. Ammonium nitrate. Again, it will be 28 upon 28 plus 4 plus 48 will be equal to 28 plus 52, 50, 60, 80 into 100. It will be equal to, again it will be equal to 35%. Okay, so the maximum percentage of nitrogen contained by urea, 47. Okay, so option C is correct. Do you understand how to solve this question? Okay, first you calculate the atomic mass of nitrogen, then the molar mass of the whole compound given in the question. Then just you have to divide and multiply it into 100. That's it. Okay, guys. So with this, I'll move to next question. Question number 6. Question number 6 is, which one of the following substance is used in the laboratory for fast drying of neutral gases? To dry the neutral gas, to dry the neutral gas, what do you need? To dry the neutral gas, you need a what? You need a dehydrating agent. You need a dehydrating agent. So they are asking you indirectly that which one of the following four compounds is a dehydrating agent. So if you have read the P block chapter properly, you know that if you react phosphorus pentoxide, with water, it is a very powerful dehydrating agent, and it gives rise to H3PO4. H3PO4. It is a very powerful dehydrating agent. Okay, phosphorus pentoxide. Option number A. It is a very powerful dehydrating agent, and it absorbs all the water and forms a compound H3PO4. Okay, guys. So with this, I'll move to next question. Question number 7. Question number 7 says a compound X upon reaction with water, like the question we solved in question number A. A compound X reacts with water to produce a colorless gas with a rotten fish smell. Rotten fish smell. Which compound is rotten fish smell? If you remember, it's phosphine. If you remember, it's phosphine. Phosphine means pH3. The gas pH3 has rotten fish smell. Rotten fish smell. Okay? And when the gas Y is absorbed in the solution of copper sulfate, it gives rise to copper phosphide. Copper phosphide. So what will be the compound X? What will be the compound X? Y is pH3. We found out Y is pH3. We have to predict what is the compound X which gives rise to phosphine. Which gives rise to phosphine. So which compound on reaction with H2O gives phosphine? It will be from the following elements. It should contain a phosphorus. Which contains phosphorus? Calcium phosphide. Option B. Okay. First you write both the equations. Okay. First you read the question properly. Then you write both the equations. Then it will be very easy for you to relate the question with the options. Yeah. First, what did I do? X reacts with water to give a rotten fish smell gas. Rotten fish smell gas is pH3. Okay. So to get pH3, which one of the following option is more related? Yeah. AS2O3 if reacts with water, you'll never get pH3. So it's ruled out. Option D is ruled out. Then for when ammonium chloride reacts with water, will you get pH3? Never you'll get. So option C is ruled out. Option A में calcium phosphate if reacts with water, will you get pH3? No, you'll get some acid, H3PO3 or H3PO4. You'll get some acids, not a gas. So option A is also ruled out. So you are left with option B, calcium phosphate. That is how you should approach the questions. Okay, guys. So with this, I'll move to next question, question number 8. Question number 8 says the number of electrons shared in the formation of nitrogen molecule is what? The number of electrons, what they're asking you is the number of electrons, which are shared in nitrogen formation. Nitrogen means N2 compound formation, N2 formation. N triple bond N. If you know, it is N triple bond N. So how many electrons are being used here? How many electrons are being shared in the nitrogen formation? See guys, nitrogen's electronic configuration is 1s2, 2s2, 2p3. Okay, so these are the 3 electrons which are being shared by nitrogen. This is the compound nitrogen forms. So how many electrons are shared between 2 nitrogen atoms? How many electrons are shared? It is 6 electrons. 3 from 1, 3 from 1. Total 6 electrons are being shared. Okay. Rest of the 2 pairs are lone pairs. They are lone pairs. They are not being shared between the 2 nitrogen atoms. Okay. Only 6 electrons are being shared. and all three are in the p orbital. Okay, one here is p sigma bond, and rest two are p pi bonds. For your extra information. So 6 electrons are being shared. Option number A. 6 electrons are being shared. Question number 9. Question number 9 asks, sugarcane on reaction with nitric acid gives rise to what? Sugarcane. Sugarcane on reaction with nitric acid gives which compound? Gives which compound? Sugarcane means sugarcane's formula, if you remember. Again, guys, these are the questions which were being asked before 2000. I don't think NTA will ever ask this kind of question, but yeah, since it is a previous year question of NEET, you should just solve it once at least. Sugarcane's formula is C12H22O11. Okay, this is the sugarcane's formula, cane sugar, C12H22O11, cane sugar. When cane sugar reacts with nitric acid, the nitric acid's formula is HNO3. This is nitric acid. It gives rise to what? Always remember, when cane sugar reacts with an acid, it gives rise to oxalic acid. It gives rise to oxalic acid. And what is the formula for oxalic acid? COOH. COOH. Or it can also be written as COOH twice. Okay? So it always gives rise to oxalic acid. So in which option oxalic acid is given? Option number B. Oxalic acid. Okay, guys. So with this, I'll move to question number 10. Question number 10 says, nitrogen is relatively inactive element because of what? See, guys, this is one of the questions where you may find all of the options are correct, but you have to mark the most appropriate one. You have to mark the most appropriate one. Okay, so I will explain all the options properly so you understand how to go for the most appropriate option. Okay, not only the correct thing, you have to go for the most appropriate. Option A says its atom has a stable electronic configuration. Is that why nitrogen is relatively inactive element? No. See, nitrogen has a configuration 1s2, 2s2, 2p3. 2p3 will be filled like this. P has three orbital, they will be filled like this. One in each orbital, it will be filled. Okay. And from the chapter atomic structure, you must be knowing the half filled, that the half filled orbitals are stable. Half filled orbitals are stable. So this can be a reason, but no, this is not the most appropriate one. It has a stable electronic configuration, but it is not most appropriate one here. Okay. So option number B says it has a low atomic radius. Is it because of its low atomic radius it is relatively inactive? Yes, nitrogen has a low atomic radius. Since nitrogen is present in the top of the group 15, this is group 15. It is present at the top of the group 15 of the periodic table. Since it is present at the top, it has a low atomic radius. But this is not the reason why it is inactive. Even fluorine has a low atomic radius. But fluorine is highly reactive. Fluorine is highly reactive. So the atomic radius has nothing to do with inactivity or activity of the elements. So option B is incorrect. Option A was also incorrect. So I'll go move to option C. It has a high electronegativity. If and it has high electronegativity, but is this the reason why it is inactive? No. So many elements has a high electronegativity. You can take the example of oxygen, you can take the example of fluorine, but they are not inactive elements, they are very active elements, they are highly active. Fluorine is one of the most reactive elements of the periodic table. Okay, so this is not the reason why it is inactive. So now you are left with option number D, which says the dissociation energy of its molecule is very high. The dissociation energy of the molecule is very high. Dissociation energy. The dissociation energy is very high. Is this the reason why nitrogen is inactive? Yeah. What did I tell you in one of the previous questions? That nitrogen has a strong p pi p pi bond. Nitrogen has a very strong p pi bond. Okay, so it is very difficult to break the nitrogen bond. That is why it becomes inactive. Once it forms its nitrogen compound, it becomes inactive. Okay, because the dissociation energy is very high. It is very difficult to separate two nitrogen atoms because of its high dissociation energy. And why high dissociation energy? Because of strong p pi bonds. Okay, so it becomes inactive. Since it is very difficult to break the bond, it becomes inactive. So option D is correct. Okay, so guys, this is how you should read all the options and you should rule out the inappropriate ones. Okay, you have to always select the most appropriate option. That is why I always ask you to read all the options A, B, C, D. Your answer might be you might think that its atom has a stable electronic configuration A. That is why it is inactive. Okay, because you must have heard that the half-filled orbitals are more stable. So you may think the option A is correct. You might think the option A is correct, but the most appropriate one was in option D. That is why I always ask you, please go through all the options, then think which one is the most appropriate, then go for the answer. Okay, guys. So with this, I'll move to question number 11. Question number 11 says H3PO2 is the molecular formula of an acid of phosphorus. What is its name and the basicity respectively? H3PO2 ka name. What is the name for H3PO2, guys? The name for H3PO2 is hypophosphorus acid. It is hypophosphorus acid. The name for H3PO2. And what is the basicity? Basicity of an acid means how many hydrogen plus ions it can release. How many hydrogen plus ions it can release. That is its basicity. Yeah. So H3PO2, if you draw the diagram for H3PO2, it will be like this: PO, POH, PH, PH. So how many hydrogen ions it can release? Only hydrogen which can be released is from the oxygen atoms. So only one hydrogen it can release. Hydrogen plus ion it can release. Only one hydrogen plus ion it can release. So its basicity is 1. Okay. So which option has hypophosphorus acid and 1? Option C. Okay. So before moving to the next question, I would like to say, please guys, You remember the name of all the acids. H3PO2, H3PO3. H3PO2 is, just now I told, it is hypophosphorus acid. It is hypophosphorus acid. H3PO4 is known as orthophosphoric acid. H3PO3 is known as phosphoric. Okay. H3PO3 is known as orthophosphorus acid. Orthophosphorus acid. Then H4P2O5 is known as pyrophosphorus acid. Pyrophosphorus acid. Then H4P2O6 is known as hypophosphoric acid. Hypophosphoric acid. Okay, guys. So there is a table in NCERT with the structure of all these compounds and with the name and with the basicity and the oxidation state. Everything is very, 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 very important. Okay. So you please write it again and again. You will definitely remember. Okay. You read the NCERT for biology. You must have had that you at least have to go through 8 or 9 times the NCERT biology. The same way you have to go through the inorganic part of chemistry of NCERT at least 10 times, I would say. Okay, because there are plenty of information. There are information in each and every line of inorganic chemistry in NCERT. Okay, so unless you go through at least 8 or 9 times, I don't think it will be in your fingertips before the exam. So please, guys, it's very important in organic chemistry. And it's the scoring part, I would say. If you remember everything, you need not even think. It's not conceptual, right? So you need not even you. It will not even take you time to think of the answer. Okay, if you know the answer, you can mark it and move to the next question. This is how inorganic chemistry is. So please go through the NCERT properly so you won't find any problem in the main paper. So I'll move to question number 12. Question number 12 says the aqueous solution of ammonia consists of what? The aqueous solution of ammonia. How can you form aqueous solution of ammonia? If ammonia reacts with water, then you can form the aqueous solution of ammonia. The aqueous solution of ammonia contains what will be the product if ammonia reacts with water? NH3 reacts with water. NH4 plus OH minus. NH4 plus is ammonium ions, OH minus is hydroxide ions. Okay, so this is our aqueous solution of ammonia. NH4 ion plus OH minus ion. Which option has the NH4 and OH minus? Option number D. Okay, guys. So with this, I'll move to next question. Question number 13. Again, the reaction from NCERT, which is important. P2O5, phosphorus pentoxide. If phosphorus pentoxide is heated with water, what will be the acid which is formed? Okay, again a part which you remember from NCERT directly. I can't help it in any. You just have to mug up this. There is no other way to remember. P2O5 when reacts with water and it is being heated. What will be the compound which is formed here? So when it is heated with water, P2O5, I told you it is a strong dehydrating agent. It has a high affinity towards water. It is strongly dehydrating agent, so it has strong affinity towards water. So it will react with water and form. First, it will form HPO3. It will form HPO3. And what is HPO3 known as? Again, the part which is important. This part is important. If you don't remember which compound is known as which acid, how will you know in which option the answer is? Do you understand the importance of these names? So if you are not remembering now, after this class gets over, please go back and read the NCERT properly, because there are some people I have seen, even if they read NCERT even if they have completed reading the NCERT, they skip some of the tables or some of the diagrams, okay, because they don't know those are important. Okay, so this is my job to tell which is the important part in the NCERT. This is one of the very important table, so please go back and read the table. So coming back to our question, when P2O5 reacts with water, it gives rise to 4HPO3. What is 4HPO3 is known as? It is known as metaphosphoric acid. It is known as metaphosphoric acid. When again metaphosphoric acid reacts with water and it is being heated, it will form H4P2O7. This is, you have to mug up. There is no other way. H4P2O7 is known as pyrophosphoric acid. Yeah. So again, H4P2O7, when it is being reacted with water and it is heated, it will give rise to H3PO4, which is known as orthophosphoric acid, which is known as orthophosphoric acid. Okay. So in a series of reaction, the final compound is H3PO4. Okay, if you want to remember, you remember the intermediates, because in they might ask the intermediate also in your future exams. Okay, it's better if you remember the intermediates also and the final product also. The final product is H3PO4. Okay, H3PO4 is orthophosphoric acid, option D. So with this, I'll move to question number 14. Question number 14 says, what is the basicity of orthophosphoric acid or H3PO4? What did I say? What is basicity? Basicity means the number of H plus ions it can release. The number of H plus ions it can release is its basicity. Is its basicity. So to know the number of hydrogen ions it can release, you have to draw its structure for H3PO4. I'll draw the structure for H3PO4. H3PO4. Draw the structure. 3PO H bonds, 1P double bond O bond. Okay. So how many hydrogen atoms it can release? I told only the hydrogen atoms which are connected with the oxygen atoms, that only can be released. So 1, 2, 3. So what is its basicity? How many hydrogen atoms it can release? 3 hydrogen plus ions it can release. So its basicity is 3. Okay, option B. So with this, I'll move to next question. Question number 15. Question number 15 says, PCl3 when reacts with water, what it will form? PCl3. PCl3. This is the structure of PCl3. When it reacts with water, what it will form? When PCl3 reacts with water, it will form again a theoretical question which you have to remember the reaction directly as given in NCERT. You have to remember the way it is given in NCERT. It will form H3PO3 plus HCl, hydrochloric acid. And what is the name of the compound H3PO3? What is the name of the compound H3PO3? By now, I think you must be remembering it is orthophosphorus acid. It is orthophosphorus acid. Okay, guys, H3PO3 is orthophosphorus acid. So option B. They can ask orthophosphorus acid and HCl. They have given the option H3PO3 here, but they might ask orthophosphorus acid and HCl. So you must know the names, the importance of names. Option 16 says, okay, question number 16 says, when you react PH4I with sodium hydroxide, it will form what compound it will form? PH4 when reacts with NaOH, the first product will be sodium iodide. It will also form phosphine plus water. Okay, these are the questions you can use your little brain. See, sodium will have a high affinity towards iodide ion. So sodium iodide is one of the products. Okay, then OH will go and react with one of the H plus atom ions here, so it will form H2O. So what we are left with? We are left with PH3. But sometimes in inorganic, these concepts are not matched. The thing which you expect to happen does not happen because it has so many exceptions. Okay, so I would not say that you use your brain in this question. I would say it's better if you mug up these things from the NCERT directly. Whatever reactions you are seeing in NCERT, please go through everything and remember those. Okay, write it again and again, and you will start remembering. Not if not in the first attempt, if not in the second attempt, not in the third attempt, fourth time at least you'll remember. Okay, so give it your proper time. Definitely, you will remember then eventually. Okay, guys. So with this, I'm moving on to question number 70. Today's last question, question number 70. And the rest of the question we will finish in our next session. So question number 17 says, pure nitrogen is prepared in the laboratory by heating a mixture of what? If you go through NCERT, in the topic, the preparation of nitrogen, in the topic preparation of nitrogen, it is clearly mentioned in NCERT that if you want to prepare nitrogen, if you want to prepare a pure nitrogen, what you can do, you can react NH4Cl with NaNO2. You can react ammonium chloride with sodium nitrate, and heat the compound. It will give rise to ammonium nitrate first. Then again, when you heat it, it will give rise to pure nitrogen with water. Okay, guys. So this is clearly given in NCERT. You please go through. If you did not know this question's answer, go through the NCERT. It's clearly a line is written. If you want to prepare pure oxygen, this is the reaction you should use: NH4Cl plus NaNO2. Okay, which will first give rise to ammonium nitrate. Then again, when you heat it, it will give rise to nitrogen plus water. Okay, guys. So with this, I'm finishing today's lecture. In the next session, I will tell you how to remember everything. What should be the approach towards your P block element, not P block, to the entire inorganic chemistry, and we'll solve the rest of the questions. So till then, goodbye. Study well.